Hello and welcome again to my Physical Science online video lecture supplement series. In today's video, I wanted to address a common question that I've received by. The question basically goes something like this. Dear Dr. Sanders, I feel like I'm struggling in your class. I'm not very good at science, and science is very hard for me. I do very well in all my other classes, but for some reason in your class I'm not doing very well. What do I need to do in order to do better in your class? What needs to change for me to get an A in your class? Or alternatively, I would just like to pass your class. You've got to help me. How am I going to pass your class? So that's the question that I would like to try and address briefly in this video. To be honest, a lot of people have told me that physical science is one of the more difficult classes that they have taken. It may not be quite as difficult as the general physics class or the introductory physics class of calculus, but it can still be pretty hard for some people. And so that means that the result is that people are going to tend to do not as well in this course. Or at least success is not going to come quite as easily in this course as in some other courses. I recognize that the typical person taking a physical science course is a non-science person. That's true of literally every person who's taking the course. If you are a science person, then you would be taking general physics or introductory physics. So this course is basically taught at the most basic level that the material can be taught at. It's not necessarily meant to be a high school level physical science course. This is actually a college course after all, so it's still going to be fairly difficult. Therefore, you should expect to have to work at it more than with a typical high school course. Now, I'll grant that maybe a high school AP physics course would be a little more difficult than this. So maybe if you took such a thing, then that would have been more difficult than this course is. Although if you took it and passed the AP exam, you probably don't need to be taking this course. With that little caveat aside, let me just say that there is a common rule of thumb that's mentioned at most universities I've ever been to. And it varies not by much from university to university. They told me this when I was a freshman going through freshman orientation years and years and years ago. They told me this when I was a graduate student starting off as a TA, as a point of interest to mention to my own undergrad students, and so on. And they've even mentioned it here in discussion with other professors. And that rule of thumb is that in a typical lecture course at a college, you should expect to spend about 3 hours outside of class for every 1 hour you spend inside a class. So a 3 credit hour class, you should be expecting to spend 3 hours per week during a 16-week semester in lecture, and then spending 3 times 3, 9 hours outside. And I should add that this is actually the number of hours that you should be spending on average. That's on average for the semester for a given course, but that's also on average for all the students in each course, and that's on average across all courses. So, some courses tend to be easier than others. Some students tend to be smarter than others. Who knows? You may be the smartest student who is taking my class. One of you surely is the smartest student taking the course, or the smartest student in this subject matter. But there's usually 35, 40, 45, 50 students taking one of these courses, even online. and only one smartest student. Most of you are going to tend to be more like the average student, and most of you have said that this is not your best subject, which means that for most of you, this is one of your harder classes. That means that you should be expecting to spend even more time in this course than those 3 times 3 hours per week outside. Maybe more like 12 hours per week outside of class, rather than just the 9 hours per week. Now, that is quite a bit of time, I recognize. And the other thing that this is assuming is that you are taking a typical semester load class. So in a semester, you have 16 weeks of class. That would be if you took the class on campus here at the main Troy campus. Now this video is mostly for the online students, which means that you are actually on a 9. This means that you are 9 weeks instead of 16 weeks for the online. That means that you're spending maybe twice as much time per week as somebody who was taking it on campus, because you're getting the same course as the person on campus, same material, same amount of material, but in just a little over twice the time. And that twice the time is including stuff like your finals week, whereas those 16 weeks doesn't necessarily include the finals week for those who are on campus. So it really does work out to about twice as much time. So what do you do with all that time? Well, I have in fact put a little sort of time commitment announcement onto the online course. The announcement itself is kind of lengthy, as you can see. Basically, it's a breakdown of what your typical time commitment would be, both for a 16-week commitment and a 9-week term. Basically, my advice is if you were going to spend 3 hours outside a class for every hour inside, you would need to spend some time reading the book. You'd need to spend some time doing homework. You might spend some time taking to the discussion boards and discussing the material with your classmates, or sending a discussion my way. If you were on campus, obviously you would come to my office hour if you needed help on stuff. And all of this breakdown is assuming that you're also spending time in the classroom. Now, for an online class, that means you're spending time going through the notes, watching the videos that I've put together for the online class, etc. For a 16-week semester, that's 3 hours a week, and that's not counting towards those hours outside of class. A 9-week semester, it becomes more like 5 or 6 hours a week. The main things that I wanted to highlight here were that if you're going to read the book, you should be expecting to spend quite a bit of time to do this. So this is a pretty big time commitment in and of itself. Basically, what I mean by that is each chapter might be maybe 20 pages or so, 25 pages, 30 for a very long chapter in the textbook that we're using. So you could probably do that reading, if you quickly read through it, maybe 30 minutes, maybe an hour if you're taking your time. And that lets you read through it one time. Problem is that that's not necessarily the most effective way of reading the textbook. When you go to read the textbook, there's a lot of new terms that you're trying to learn. There's a lot of new concepts that you're trying to learn that you're not necessarily familiar with. These are a little different than reading other types of book. Maybe you sit down and you want to read your favorite genre of story or something. So you sit down, you read a story, there's a large ensemble cast in the story, characters kind of pop in and pop out of the story, maybe it's narrated by a first person, and in order to really enjoy that story, you have to find some way of keeping track of all the different characters and events that are happening. You may find yourself going back and rereading previous chapters or previous sections, previous pages, what have you, to make sure that you've got all of the characters straight. Maybe the author is really nice and they give you sort of a dramatis persona at the beginning that you can quickly flip back to and look at the list of characters to try and keep track of who's who. But if there's a lot of characters in the book, you may be finding yourself doing that quite frequently, or you may be finding yourself flipping back to the previous chapter on occasion to read and make sure that you understood what the events of that chapter were. Maybe there was a shipwreck or something and you want to go back and check and see who did what during the shipwreck, because this helps determine who was the saboteur or whatever. So when doing physical science or doing physics in general, science, etc., you may find yourself needing to do something similar here. Case in point, if you're doing a chapter on kinematics, you're introduced to stuff like position and displacement and velocity and acceleration. And later on in the chapter, it starts talking about how the acceleration going around a circle is related to the radius of the circle and the speed that you're traveling around the circle with. Well, if you don't have in your mind a clear distinction between speed and velocity, let alone between velocity and acceleration, you may need to go back and reread the earlier section that explains how these things are related to each other, that explains that speed and velocity are different because velocity is a vector and it has a direction to it, whereas speed just tells you how fast something's going. You may need to go back and reread the section that explains to you that an acceleration is not the same thing as a speed, or a vector acceleration is not the same thing as a velocity, but rather that an acceleration is a change in speed or a change in velocity, and so on. So you might, when you're reading the book, read through the whole chapter in one sitting, and then go back and read section by section. Go back, read the third section and make sure that you understand what's going on. Go back and read the second section after having read the third one. Then read through 3 sections, then jump back to the third section as necessary. The book often has little examples and conceptual quizzes. Make use of those. There's answers to all that stuff in the book at one point or another. If it's a conceptual quiz, you can go look up what the answer to the conceptual quiz is. Test yourself. Make sure you understand what's going on. Similarly, there are examples worked in both the notes and the book. You can sit down and work through those examples without looking at the solution and then compare your solution to the solution that's given. I usually try to provide a few examples in my lecture notes that are different than the examples in the book, but that are similar enough that you could try to work through one just to see how it's done and then work through the other. For example, you take the book's example, read through it, work through it, then sit down with the question posed in my example and try to come up with the solution on your own, and then look at what I did to actually get the solution. So, this whole reading part of it includes doing all of this stuff, and that may be, you could easily sink 8 or 9 hours a week into just doing that on a 16-week semester. You could easily sink 9 hours into each chapter just to be sure that you really have it. Then you have the homeworks. Now the homework you have to turn in if you're on campus, but online, I'm not really collecting the homework. You may have noticed that the quizzes I put online actually use a lot of homework questions in them. Or they use questions from the homework or example that I've changed a couple numbers in. So if you know how to do all these things, then you should do fine on the quizzes. What you may want to do, though, is, if you want some extra practice, I don't assign every single multiple choice question, and I don't assign every single homework question. I largely assign them in such a way as to sort of restrict myself by saying, okay, the quiz is going to pull 5 questions off of your homework somehow. So they're going to be out of these 5 that I've assigned. Feel free to work through the ones I don't assign because a lot of them are similar to the ones that I do assign. The book, for what it's worth, provides you with the answer to half of the exercises, all of the multiple choice, and all of the key term and matching problems. So you can always go look and see if you got the right answer to make sure that you're actually doing things correctly. And if you keep working through something and you can't get the right answer, that's a good time to go to the discussion board and ask people, other people in your class, how to do the problem. And if nobody in the class is able to figure out, that's a great time to be asking me how to do it. I'm more than happy to work through a solution for you when you've exhausted all of your other avenues for trying to solve this problem. I kind of am assuming that you're spending about 4 hours on the homeworks. This is because it takes me something like maybe 1 hour or so to write up all the solutions to the problems that are going to be on your homework, if that. And I'm assuming that you're going to spend several times longer than I am to actually struggle through the problems because you don't necessarily know how to do them upon sitting down and looking at them. Often I can get through your whole homework in 30 minutes, so I figure if you're struggling with some stuff, you can get through most of it in about 4 hours. But you may have to rework that homework. For example, you're probably not going to get everything right the first time through. It may be a good idea to go rework some of the problems that you got wrong. It's also a good idea even to rework some of the ones you got right on a different day just to make sure that you really do know it. So again, if this was on campus, you could easily spend 3 or 4 hours a week on the homework, bearing in mind that the homework would be every other week. That means about twice as much time per week online, 6 hours, 7 hours, 8 hours to work through the homework part of it to make sure you've got it. So if you're doing all of this stuff, you will find that you are in fact developing the skills needed to be successful in this course. It's worth noting that science is itself a skill. And like any other skill, it's something that you have to develop by doing, not just by seeing. You can't develop skills by sitting on the sideline and watching somebody else do something. You can maybe develop a little bit of a skill. You might, for example, if you were playing a sport, yeah, sure, you can watch game film and pick apart what you've done wrong or pick apart what your opponents tend to do when you've played them in the past. But a lot of the skill you're going to end up developing by actually going out and playing that sport, practicing it hard, drilling certain skills in that sport. The same thing is true of anything else. Woodworking, you don't develop it by watching a video of somebody else building a bench. You have to actually sit down and pull out your tools and sort of go through the process of building that bench. Skills are something that you develop by doing, and science as a skill is no different. That means that in order to get through this course successfully, you should be treating it like a skill that you're needing to develop. For my class, that basically might look like practicing the homework once or twice through, practicing the examples that I provide, practicing the examples in the book. You can even, if you so desire, go seek out new examples online, although that wouldn't necessarily be my first recommendation. And furthermore, by discussing these things with your classmates, because sometimes when you discuss stuff with your classmates, they've got some insights that you're lacking, you've got some insights that they're lacking, you're able to actually show them how to do something, and that also helps you to hone your. And if you do all of this, I think that you will find that the course ends up being a little more successful, that your grade will improve a lot in this course. You may even find that you're able to make that A that you're hoping to earn in this course. And if you do so, then congratulations, you will have survived what many of you consider your toughest course, and perhaps someday you will even think back and think of it as one of your more valuable courses because of that struggle. Certainly, I hope that some of you find that to be the case. So I hope that you all find this video helpful and maybe a little inspiring, and good luck.